Good morning, everyone. My name is Nikta Sarkar. Today's session will be using Ansys SpaceClaim Direct Modeler for FEA geometry prep. And this session will be presented by my colleague, Mr. John Dow. And with that, I let John take it away.
Thank you, Snigdha, for that warm welcome. So I'm a senior applications engineer over at KETIV, and I specialize in the structural products of Ansys. And here at KETIV, we believe in sharing the knowledge that we have obtained to empower today's innovators and manufacturers for a better tomorrow. So for today's AVA, I'd like to go over an agenda with you all. I would like to do a brief overview of pre-processing for the finite element analysis method in Ansys, and that's going to be with a program called Ansys SpaceClaim. And we're going to walk right into a demonstration of how I can fit this tool into my workflow. So let's go over an overview of Ansys SpaceClaim. As an engineering analyst, where would SpaceClaim fit in my workflow? We have a 4-step process for the workflow for finite element analysis. And we usually start by defining the problem, understanding of our design and what we want to simulate, the type of physics and what we want to do. And comes preparing our CAD geometries to perform what we have defined. So usually we need to apply our boundary conditions and loads. And that starts by taking that CAD geometry processing part and preparing it so that we can properly mesh it and turn it into a different type of model for the finite element method. And that's where Ansys SpaceClaim fits in. Ansys SpaceClaim is a direct modeling tool. It's meant to complement your CAD. So let's say if you get a CAD file and you want to make modifications to it, Ansys make direct simplifications and modifications of that geometry. One of the benefits of Ansys is that you can rapidly make these changes without the consequences of linked relationships from your CAD. So on the left side, you could see an error message from somebody that took a CAD file and they went in their feature tree and made a change on the top of their feature tree, which broke a link somewhere. Or rather, they made it in the bottom of their feature tree. And it broke a link and it's causing an error. And usually when I run into these type of errors when I'm using CAD software is I have to close it down because I don't want that error to exist, and I have to reopen it and make and observe and break the links properly to make changes. Ansys SpaceClaim is going to import your file as a single. On the right side, you can see here, it's going to import your 3D model as a single object for you to make modifications. There's no history for us to have to worry about. So we get to make these changes without any consequences. And because of that, we can rapidly make design changes through optimizations. We can make not just changes, but we could also create new geometries. Ansys SpaceClaim has many features that are very similar to your CAD tools, for extruding and cutting or making rounds and chamfers. Here are some examples I have here in these screenshots. Credited to these images were taken from Ansys. You can also use a tool to rapidly repair geometries. So how often have you accidentally made a feature using a spline line? That's going to come in with many different edges, right? So you can see something on the bottom left. I could import something from my CAD and have multiple spline lines. Ansys SpaceClaim can fix that with a click of a button. And what happens when there's a bad import and there's extra edges? These are the type of questions that I had before I was introduced to Ansys SpaceClaim in my career. And when I got the tool, it rapidly improved my workflow. It also has powerful defeaturing capabilities, removing features also at a click of a button. And it's as simple as selecting a feature and removing them. So it has a powerful ability to defeature to prepare your CAD geometries for your finite element analysis. And of course, all these features I'm showing you are, Ansys, it's not limited to. There's many different features that Ansys has, Ansys SpaceClaim can do. And that's where it does a lot more. It can do meshing, additive manufacturing, reverse engineering from 3D scan, and much more. But for today's AVA, we're going to focus on the first 3 bullets. That's optimizing our designs, repairing, and defeaturing. So I'd like to hop into the demonstration. And if you have questions in regards to Ansys SpaceClaim and the stuff that I'm going to show you in this demonstration, please feel free to fill out our Q&A forms for this chat. We're going to have a Q&A session at the end, and we would like to address your questions and make this interactive. And at the end of this AVA, we're also going to have a survey for you to give us feedback on our AVA. And if you would like to try Ansys out for your company or you're entertaining Ansys, please let us know in that survey as well. That's how it's going to be easy for us to get back to you. So let's hop into the SpaceClaim demonstration that I would like to share with you all today. We're going to set up a little story here. You're an engineering contractor, and your client has hired you to do a simulation to get a stress analysis on a swing set for a child. Now, there's a problem with this CAD that we received. It's considered a dirty CAD, meaning that there are a lot of issues with it for us to set up for a simulation. There's going to be interferences, and there's going to be unnecessary features for us. Before we can get started, we need to clean this CAD up. And let's also assume that when we budgeted this project, we did not budget for making these changes. So we need to do it rapidly, or else we'll start to lose time and money. That's what Ansys SpaceClaim is going to benefit us. Do an overview of this model. It looks pretty simple. It looks nice as an appearance in an isometric view. But there are actually some issues that I'm going to point out to you all. And we're going to fix these issues with SpaceClaim. How often have you used a CAD program that's really nice to do line bys and extracted profiles, or extruded profiles, I mean, and there have been interferences because we did not take the second step to cope to fit or miter some of these features here. Those are interferences that I have often come across when receiving a CAD file. There are features that are unnecessary that for our analysis. It's nice that we have a logo that designed the swing set, but that logo is not necessary for our analysis. That's going to cause some bad quality meshes. And in a further inspection on the hardware, we can see that somebody was pretty ambitious when they designed this, when they modeled up this screw. They modeled everything, the threads, the hex, and these are features that are not necessary for our analysis because we're worried about the swing set itself. How can we take hardware like this and defeature it so that we can not only limit the amount of nodes and elements on these 3D parts, but also get a more higher quality mesh. As you can see, versus on the left side, I have a TET mesh. You could see a lot of low quality elements versus on the right side, we can see the Ansys was able to produce a nicer high quality mesh with hexes. And that was using Ansys SpaceClaim and its defeaturing capabilities. And also the question is, do I even need to model the hardware in? Can I form split lines on surfaces so I can apply my boundary conditions such as fixed displacement or loads? That's something that Ansys SpaceClaim is very powerful in. And lastly, I'm going to show off a pretty cool feature of Ansys SpaceClaim that was very useful for me. It's the ability to quickly form shells and beams with a few clicks of a button. For this AV, going over how to do it in SpaceClaim just to set it up. But how to do the simulation itself with beams and shells will be a part of another AVA. So please join that one if you're interested. Let's get to the demonstration. I'm going to load up Ansys SpaceClaim. It's just going to take a second because it accidentally closed down. I apologize. And right away, you can see the UI of Ansys SpaceClaim looks very similar to your CAD. There's ribbons on the top. And if I go from left to right, there's explanatory. We have features and tools to do design, assemblies, repairing CAD, preparing our CAD, and transferring it to our simulations in our Ansys tools, such as Ansys Discovery Product or Workbench and Ansys Mechanical. I'm going to start by clicking File, because that's the leftmost where I should start. And I'm going to import this CAD geometry. And by the way, Ansys SpaceClaim is CAD agnostic. You can see over here on this list, it supports various different CAD. Your most popular ones. You can see there's Creo, SolidWorks, Inventor, you name it. And it's pretty it's CAD agnostic. But I see this swing set over here. So I'm going to open this. And here we have our swing set. And you can see on the left side that every body that's come in has come in as a single solid body. I do not have a history of how this body was created. So the links are broken from my CAD. And that is what allows me to make these type of rapid changes. Rapid changes as taking a look at this logo over here, which is nice from our customer, but removing it really quickly by just selecting this logo. And I'm going to use a powerful feature, the delete key on the keyboard. And all I'm going to do is hit the delete key on my keyboard. And that feature is gone. I can hit the delete key to remove many different type of features that I might not want in my simulation. For example, I'm going to click on the radius of this tube. And by clicking on this radius of this tube and hitting the delete key on my keyboard, I have defeatured it. And there are no consequences for any linked parts that you might have in a CAD. It's a designer and can remove a bottleneck if an engineering analyst receives a CAD file from the designer and they need to make rapid changes. I'm going to move down to this bolt over here. And I'm going to defeature it. Oops. Hide others. So what's the goal of this hardware? I'd like to turn it into two cylinders. And I see a lot of different features on this bolt. I want to first start by removing this hex. What I'm going to do is I'm going to select all the features that I don't want part of my simulation. So let's select these surfaces here that I'm interested in removing and defeaturing. And let's hit the delete key on our keyboard. Ansys SpaceClaim has guessed the right defeaturing. There's still some surface I need to remove. And let's select those surfaces and hit the delete key again. There, we have the cylinder on the top. On the bottom, I have an anti-slip on this screw. And how can I remove that really easily? I'm going to use a different tool besides the delete key on my keyboard. I'm going to use something called split body. And what split body does is it allows me to select an I'm interested in splitting up. So when I click on this hardware, I'm ready to start splitting it apart. And I'm going to remove this feature by using the top surface above it. And by clicking on this, it's going to cut and split everything below. So you can see now that this feature, the anti-slip of the screw, has been separated. I'm going to click Control-Z on my keyboard, or the undo button. By the way, I'd like to mention that Ansys actually has Ansys SpaceClaim has a really nice undo and redo feature. Sounds like something that can be taken for granted, but if anybody that has worked in the CAD space knows that anytime you hit Control-Z, there's no Control-Y, so there's no undo and there's really no redo, because once you undo something in CAD, most of the time you cannot redo that process. I could simply hit Control-Z and go back again with Control-Y. So I'm gonna go back to the split feature, split body feature, and show you some other cool things that it can do. All right. So let's use a split body feature to remove certain features that we don't want. I'm gonna click the screw, but this time I'm gonna hit merge when done, because I want the bottom of the screw to remain. And when I hit this to split everything on the bottom, you're gonna see up on the top left here, it really asks me, what bodies are you interested in keeping and which ones are you interested in removing? I'm not interested in keeping this feature, so as I click here, it's now gone. At this point, I could also remove the bottom of the screw, but I don't want to do that. I want to keep that feature. So I have the merge when done still selected, and I'm gonna hit escape. And this screw, let's see over here, hide. Oh, that shouldn't have happened. One more time. Split body, merge when done. Remove this feature. Click off from the left. Okay, so the screw is still a hole. Now, the next feature I'm interested in is removing these threads. I'm going to use the split body feature again. And this time, I'm going to select the cylindrical face over here. I'm going to use this face to cut any part of the body that this face intersects with. So when I click on this cylindrical body, part of the body, I now have the option to remove features that I'm not interested in, which are these threads. And just like that, I remove those threads very easily. And lastly, I'm just going to remove this feature here because it's not necessary. I'm going to hit the delete key on my keyboard. I did various different defeaturings with just two features from Ansys SpaceClaim. That's a delete key on my keyboard, and that's that split body. There are various tools that you can use to help defeature, and these are just two of them. Now, the next part of the demonstration I want to go over is, what if I didn't want to use this hardware here in my simulation? Just apply the load directly on this bottom plate here. That could be done simply by using this feature called split. And what split does is it allows me to create split surfaces on the parts using other CAD or other geometries. So I'm going to click on this surface here, and I'm going to select the hardware that I want the profile, where the profile bolt is intersecting with this plate. And when I click on this surface, we're going to see that it created a split body right there. And now I could apply my loads and boundary conditions to these type of split surfaces. No longer do you have to go into your CAD, draw on the surfaces, do a full drawing and then split it. You can use Ansys SpaceClaim to split lines like this. Now, the next feature I'd like to show off is the ability to fix interferences pretty rapidly and quickly. I have these tubes, these smaller tube arms intersecting with this large swing tube. I'm going to, again, use this split body feature. And I'm interested, I have to select the geometry cutting apart. It's going to be this one. And what would I like to use to cut that? It's going to be this tube over here so that they intersect. I'm going to remove that and it's gone. And I'm going to continue to do that down the line. You can see that I'm fixing all these interferences with just a few clicks of a button. So let's go through here. The surface and remove it. Ansys SpaceClaim also has something that automates this process for me. I could look up interferences and select to remove them just by going over to the Prepare tab and clicking on interferences. And it's going to highlight the interferences in red for me. And I could click and start removing these features as well. I don't have to use a split body. This is actually a faster way to do this. Look how fast that's happening. And let's take a look at how my simulation looks. When I import this into Ansys Mechanical, I get a pretty nice quality mesh just by using those G features. I removed the logo so that I can get a nice mesh across this face. If I were to mesh that logo in there, it would lower the quality of my elements on this tube body. There are no interferences intersecting geometries to stop my simulation from running. I have defeatured this hardware over here so that I can apply loads onto them if I wanted to, or use them as boundary conditions. And I have also used that split surface I made so I can apply some boundary conditions and loads without that hardware there. Oh, look at that. What's this line here? It's actually an extracted 2D type of element called a beam. Sorry, it's still in 3D space, but it's a 2D line in 3D space. I guess that doesn't make sense. And how can I make these type of features? I could use Ansys SpaceClaim to do. I could use Ansys SpaceClaim to do beam elements as well, to set elements. And I'm going to walk you through that. Let's use Ansys SpaceClaim. Did it close down? Nope, it's over here. Let's use Ansys SpaceClaim to make shells. Now, this is something that can be very tedious in CAD, and something that we can do pretty rapidly and quickly using Ansys SpaceClaim. I'm going to click on this Midsurface feature over here. And I'm going to use a range. I want to look for plates. I know the thickness of all these tubes on my plate here, 1/4 inch. And I'm going to drag and select. And Ansys SpaceClaim is going to search for mid-surfaces that I can make. And with a click of a button, I can turn all of these tubes And that allows me to do a shell analysis in SpaceClaim, which I'm going to show you over here. In Ansys Mechanical, sorry. I'm doing a simulation over, in this simulation, I used Ansys SpaceClaim to set up the shell model. And I did it very rapidly and quickly. Let me display over here the thickness of the shells, of the elements. And I did the same analysis I did with the solid bodies, the shells. So let's get a little preview of that. I'm going to click on, and I'm going to go over to the shell body, click on deformation, try putting these simulations side by side. And you can see the deflection, guys. And can Ansys SpaceClaim do extracted profiles and beams? Yes, it can, and it can do that pretty quickly. So let me hide this ground body. And let's use the beam extract tool to quickly create beams. And I'm just clicking on these bodies and they're turning into beams. Failed to extract beam. I think that's because when I defeatured it, I did that wrong. This can happen, and we could fix this. Fix this over here. See the support arm. Let's remove this feature. All right, so I'm just gonna have to select these bodies. Let me backtrack a little bit. And this is why the controls, the undo feature of SpaceClaim is really important for me, because if I make a mistake, I can go through a history of things I've done and undo them all. Let's see, where did I leave off? I had to use the interference tool. All right, let's just start from here. And once again, I'm going to extract these into beams. Click of a button. And I've turned these into beams. And Ansys SpaceClaim is going to use the beam it's going to find the beam profiles and it's going to store those for us here. Area information here. That's what it's going to use. It's going to transfer that over to our simulation. So we don't actually have to fill all this information out for the beams. It's actually going to transfer right over to Ansys Mechanical. And I could see that some of these beam areas, they're not connected. There's a space here. So I could quickly fix those with the feature. I can click connect, find these gaps. Let's use a target range of 1 inch. And it's going to show me areas where these beams are not connected. And just by clicking on these red highlighted areas, it'll connect these beams and fix that feature. And let's take a look at how that simulation looks, where I use beams and shells combined together to do this simulation. And you can see the deflection. It's very similar to our other results. So let me pull up other solid bodies. And here's a little table comparing the solids, shells, and beams and shells method. And here are the deflections, the large that were obtained from our load case of a child on the swing. Very close. The answer, these results are in inches. And here are the solve times. It took the shell model only 18 seconds, and it took the beam and shell only 10 seconds. And I wanted to go over the beams and shells because I believe this is going to be one of our future AVAs, because it's a really important feature for somebody that has to work on very large structures, such as or a frame for a body, a frame for a vehicle. And this is going to be a future AVA. So the main takeaways for using Ansys SpaceClaim are that it's a tool and rapidly and quickly make changes to geometries. We use Ansys SpaceClaim to make some optimizations, to repair some bad geometries and intersections, and to quickly extract beams and shells from it. And that concludes our AVA for today. Our next session I would like to invite you to is going to be performed by our AE Snegda Sakar. It's going to be on Ansys fluent meshing using watertight geometry to guide for guided workflow. That's going to be on June 23rd, 10 a.m. And if you haven't, please fill out the survey. We're going to hop into the Q&A portion of our webinar here.
Thank you, JD. That was really informative. I learned a lot myself, me coming from a CFD background. You know, learning some tips and tricks for FEA analysis is really great. I think you showed a lot of important steps that might be necessary for someone who's starting off with either SpaceClaim or just starting off with FEA analysis. So thank you so much. And yeah, you know, we have some questions in the Q&A box. I'll let you take a minute to go through them.
Okay, let me see here. Let's see here. There's two questions. What is, okay, Prakash is asking, what is penetration and contact? Get correct. Prakash, I see your question here that has to do with penetration and contact. That is a good question. That's important. And I believe that should be an AVA in itself. Connect with you and talk to you about connections and contacts. But for today's AVA, we're going to focus on using SpaceClaim. So please continue to ask questions about SpaceClaim. We'll do a future AVA on features such as connections in Ansys Mechanical and meshing. Where did you put the loads in the geometry, in SpaceClaim or Workbench or Mechanical? So Bonnie asked, where did you put the loads in your geometry? Did you apply them in SpaceClaim or did you apply them in Workbench? It's a good question. SpaceClaim does not apply our loads. I would like to actually. What SpaceClaim can do is it can do some pre-selections for us. So let's say if I wanted to use SpaceClaim to create a group on these plate surfaces, I could select them and create a name selection. And what that does is anytime I click group 1, it's going to select those. You might ask why that is important, and it relates to Bonnie's question here. Where did I apply the loads? I didn't apply the loads in SpaceClaim. I'm applying the loads in Ansys Mechanical, but these name selections transfer over. So you could see I created this name selection from Ansys SpaceClaim, and I transferred it over to Ansys Mechanical. And what that does is it pre-selects those surfaces that I was interested in earlier. And if I want to, I can create loads and boundary conditions on those surfaces automatically. So that saves me some time. Normally, I would have to apply a force on these surfaces manually. But I can go to these name selections that I created in Ansys SpaceClaim. Fixed. And I can apply loads and boundary conditions onto them. So to answer your question, Bonnie, when I did that split line surface, I wasn't applying the loads and boundary conditions in Ansys SpaceClaim. I could have a pre-selection done in Ansys Mechanical. Let's see here. Is this session recorded? Yes, this session is going to be recorded, and it's also going to be uploaded on our YouTube channel. So please join our YouTube channel. Subscribe to our YouTube channel. Someone asked, is it possible to make merge as a default setting when you do add and cut? That's a good question. I actually don't know the answer to that, and I've always wondered that myself. So we have an anonymous attendee asking about when we're making features, can we have it so it doesn't automatically merge the bodies? Let's see here. So I'm gonna show you what this person's talking about here. I'm gonna hide those other bodies. So if I made a modification to this tube here, if I pull it, it's going to merge these bodies as one. Actually, no, it did it this time. It's funny. Let me go back. So if I want to extrude this surface, and by pulling it, I can see on the over here, there's some detailed settings here that give me the option to add or use this feature as a cut, or use this feature, if I don't want to merge this, so these two bodies don't merge together when I do this pull. But to answer your question, I got to get back to you on that one. I don't know how to change that default setting. Is there a general rule of thumb of thickness where using shell elements is no longer valid? That is a good question. Ansys has two different type of shell elements that they use. There's one for thick and there's one for thin shells. What is the limitation is going to depend on, there's an equation I don't have in front of me, but it has to relate to thickness versus the length of and your volume. So an item like this, it's good to shell because it's long and it's relatively thin compared to the length. I wouldn't, for example, shell a block. And when we go into the AVA for beams and shells, those are type of questions I would like to cover. Let me see over here. I think we have a question from our YouTube channel. Let me just pull that one. Shells is the quickest process, but it's accurate. Would you say that beams and shells are the quickest method to do an analysis, but the least accurate? Yes, solid geometries are going to be more accurate in most cases, if not all. And the reason why I say that is what I like about using beams, it helps me get quality mesh, especially when there's some surfaces and geometries that might screw up the simulation over versus a solid. And it does help with time. You can see that there's a time difference here, but beams and shells, they introduce some more error than solids. So solid geometries, to answer that question, solid geometries are always going to be more accurate than shells and beams and shells. But depending on the complexity of your features, the shell actually might be something easier to use. I might have a pretty complicated surface geometry that I cannot get a nice high quality mesh on, and it might be a solid. If I had a hood of a car, of a Lamborghini, for example, and I wanted to do a simulation on that, that hood might have a strange contours and geometries, and it might be hard for me to mesh something like that. But I can use a shell method to turn that into a shell, and that might actually give me the ability to start an analysis versus defeaturing and taking a while on the solid body. Let's move on. Our next question over here. Is it possible to make an assembly file directly from SpaceClaim instead of importing it? Yes, Ansys does have some assembly features. You know, all these bodies I have in here, they're not combined together right now. I could choose to combine them using the combine feature, but right now they're set up like an assembly, and I can actually use a lot of assembly features here that you find common in your CAD. You know, there's tangencies, alignments, and orientations. So that answered that question. Okay, all right. Pawni's saying that I addressed her question. Let's go to Pramod's question here. With the mid-surface approach, what is the best way to connect two components with a gap after mid-surface extraction? Okay, so this is a good question. Someone asked about when I form my mid-surfaces, what happens if there's a gap? Because when I form a mid-surface, let me take these two tubes here. Let me split this body. This question is asking, what's the best method to make sure that there's a connection or the surfaces are touching? So let me delete this logo over here. And let me go back and reuse this tool. If this feature down here is extend surfaces is not selected, what happens is a mid surface is going to be what it says. It's going to be it's going to create a surface in the middle of these profiles. Let's just create this real quick, and you're going to see that the mid surface is going to be made in between the thickness of this material. So when I click OK, and you can see that there's a gap over here. And someone's asking, how can we close this gap easily? That's actually, when I start this analysis, I would make sure that the extend surface is selected. So when I click that, it's automatically going to extend that. Why didn't it do it? It should have extended that surface for me. Let me try to redoing that again. Surfaces. And then extend surfaces. Yes, please extend the surfaces. Huh. I don't know why it's not doing it this time. Usually when I have this extend surface, there must not be working right now. See, it should automatically extend these surfaces. It's not doing it right now, but I guess the other method I can use is to pull this feature, select the direction I want to pull it in, pull it up to the surface. Let's see here, it's not working. I can pull it up to this surface over here. All right, it's 10:45. Why do you use the beam element to represent bolts? Why not 1D element? All right, somebody's asking about using the beam. That's a good question. And I think that's gonna for AVA that I would like to do on doing simulations with beams and shells. We could cover that in another AVA. So someone's asking, why did I select to use this beam to represent the hardware instead of using this solid body over here? And that's going to be covered in another AVA session. And I have time, I believe I have time for one more combination or question. Can a combination of shell, solid, and beam in the same model be used with reasonable accuracy? Yes, and that's what I showed over here. I have a simulation done with a combination of, let me go back to this. You can see these are shells. There's some beams in here. And the accuracy for this analysis, for the beam and shell method, you can see there's some accuracy sacrifice where solid's the most accurate one. We see a slight difference. Here's my advice to you. I use beams and shells initially so that I can do a quick simulation. Let's say if I had to do a frame and there's 200 tubes that are connected together, I'm going to use beams and shells to do an initial pass so that I can understand where my areas of high stresses are occurring. And that I will do a sub-modeling and simulation of that area. What am I using beams and shells for? I'm really using it for a fast analysis so that I can find the area that I should focus in and do a simulation on. And of course, that's going to be covered in a beam and shells analysis. I'm really happy about all these questions, beams and shells, because it's telling me that that's actually an AVA that we should do on doing simulations with beams and shells. Can you share the geometry used in the webinar? Yes, I can. Please ask that question in the survey. Send the model over to you. I could also archive my simulation and send that to you as well. Okay, I believe if I didn't get to your questions through this AVA session, I'm gonna get back to you. I'm gonna email you, but it's 10:50 now, and I believe we're running over time. So thank you all for joining our AVA. Please fill out the survey. Yeah, go ahead, Snigdha.
Thank you, JD. I was just going to say that, you know, please be sure to attend the next session, which will be presented by me. It's going to be using Ansys Fluent Meshing for clean CAD geometry. I think that'll really be of interest to those who are looking to start with CFD or optimize their CFD workflow. But thank you, JD. That was a great presentation, great questions. And yeah, feel free to fill out the survey. Yep.
Thank you all.
Thank you, everyone.
In 2 weeks. Bye.
Bye-bye.